important panel discussion that's been organized by two of our prominent fellows of the Indian Academy of Sciences, Prof.LS Shashidhara and Professor Satyajit Mayor. We consider this panel discussion to be topical and important for reasons that Shashi and Jitu will inform us, and all of you have assembled here to educate us about your thoughts. And the entire panel discussion is called Why Do We Need Data Science and Statistics to Count Deaths During a Pandemic? Without further ado, let me hand over the microphone to Jitu and Shashi. Jitu, please go ahead.
Thanks, Partha. Well, first of all, on behalf of Shashi and myself, I'd like to welcome the members of the Indian Academy of Science, fellow scientists, members of the general public, to this panel on, as Partha mentioned, why do we need data science and statistics to count deaths during a pandemic? While I will open this session, Shashi will provide the closing remarks. And it's appropriate that we follow the science and philosophy lecture we just heard from Thomas Perdue, since our session is about science and its other engagements, in fact, its crucial engagement with society. I must, in fact, begin by expressing at least Shashi and my sincere thanks to the Indian Academy of Sciences, in particular to its president Partha and the secretaries Rene and Umesh, for immediately agreeing to hold such a panel when we proposed the same to them a few weeks ago. I also thank all our speakers and panelists who have agreed to join at very short notice. We have never put together, in fact, I'll say this for myself and Shashi, never put together a panel as fast as this one. It's a real testimony to the need that we all feel to discuss the topic at hand. Yet, you may ask, why are we doing this in a scientific session of the annual meeting of the Indian Academy? Well, as scientists and as citizens, we have witnessed an extremely traumatic time over the last 2 years due to the COVID pandemic. All forms of normal life and lifestyles have been thrown out of gear, and we have seen extreme hardship up close and personal. We've also witnessed extraordinary acts of courage and humanity in the face of this terrible pandemic. In all this, I must add that science has led from the front, providing solutions to combat the disease and ease our suffering. For example, the mRNA vaccine or the recombinant viral vector vaccines would not have come to become so prominent a tool in our toolbox to combat the disease if we had not invested in understanding the fundamental aspects how biological systems work, in fact, deep science, and over decades of research. Governments and some companies have also had the courage to put forth spanking new technologies to combat this disease at this time, changing, I would say, forever, how we in our lifetimes will view biology and its attendant technological prowess. However, some of our friends and family members and countless others we will never know are not with us today. And we do not even know how many of our fellow human beings we have lost in this pandemic. Whilst today we are able to find a signal in almost impossible swaths of noise, drowned by noise, but in fact we can determine our ancestry in sequences extracted from ancient DNA. As we heard so eloquently this morning from Partha himself, we can infer the existence of gravitational waves, find the Higgs boson, or even see a single hydrogen atom in a cryo-electron microscope with the aid of data science and statistical tools of inference. So, in the loss of lives during this pandemic, we as scientists are also accountable, at least in knowing how many did not make it through this time. Can we not use the power of these methods to determine how many people died due to this pandemic, as counting all deaths during the peak of a pandemic is difficult, and especially in our country, wherein access to records are not readily available or made available. To address this singular question, we have invited three people who have been working in this area from their own disciplines. Arvind Subramaniam, a former Chief Economic Advisor of the Government of India, Rukmini Srinivasan, journalist, and Prabhat Jha, public health researcher, to provide their perspectives about the data that is available and the science behind determining these numbers. We have also assembled an eminent panel of mathematicians and statisticians: Murad Banerjee from Middlesex, Maninder Agrawal from IIT Kanpur, and Madhu Bhattacharya from University of Hyderabad, to discuss the strengths and weaknesses of these results, so that we may come away with an idea of the magnitude of what we have faced during the past 2 years in terms of the deaths that have occurred. We have also invited two physicists, Gautam Menon and Mukund Tattai, who have been working on various aspects of building models to understand the ebbs and flows of this pandemic. I must say, but Mukund regrets that he cannot join us today due to a family medical emergency. But Gautam is with us today. Gautam is Professor of Physics and Biology, as well as Director of the Center of Climate Change and Sustainability at Ashoka University. He will introduce our speakers and moderate the panel. He will also provide you with the rules of the engagement in this virtual meeting. Thank you all for coming, and over to you, Gautam.
The title of this panel discussion is, why do we need data science and statistics to count deaths during a pandemic? This makes one implicit assumption, and it's not about methodologies of data science and statistics. That assumption is that it is important to count deaths that are a consequence of a pandemic disease, and to count them well. And this is not just an academic exercise that scientists might engage in. So I hope this session will make that point clear to the audience of why we need to count deaths better, as well as to highlight the many subtleties that arise in doing so. And we have a wonderful set of panelists to guide us through this. So this part of the session, from now on, there are three parts to it. The first part will feature talks by Professors Arvind Subramaniam, Prabhat Jha, as well as Ms. S. Rukmini. Each of them will have 10 minutes to describe their own work on counting pandemic deaths and their own approaches to the larger question of why this is important. I will introduce each of them separately before they speak. The second part will add three further members to this panel: Professor Maninder Agrawal, Murad Banerjee, and Madhuchanda Bhattacharya. I will ask them each in turn one question that takes off from what we heard from the first set of speakers. And I'll ask them to respond within 3 to 5 minutes with reference to their own work in this area if required. In the last part, we'll take audience questions that will be relayed to me. So enter your audience questions into the chat or into the Facebook Live proceedings. So let me start with Professor Subramaniam. Let me start by introducing him. Arvind Subramaniam is a senior fellow at Brown University's Watson Institute for International and Public Affairs and distinguished non-resident fellow at the Center for Global Development. He was previously professor at Ashoka University, a visiting lecturer at the Harvard Kennedy School, and chief economic advisor to the Government of India between October 2014 and July 2018. Professor Subramanian's areas of interest include global development and the global economic, financial, and trading systems. But among the work he's done most recently is to use data from economic and social surveys to address the question of undercounting of deaths from COVID-19 in India. You have 10 minutes.
I want to begin by thanking the Indian Academy of Sciences and the organizers, not just for inviting me, but also for holding, I think, this very important session on counting deaths and so on. So I will try and I have a presentation. I'll try and rush through that quickly. And Gautam, please let me know maybe a couple of minutes in advance, just by saying I'm okay. So the title, this is joint work with two colleagues, Abhishek Anand and Justin Sanderford, 3 estimates of all-cause excess mortality during the pandemic. The motivation for this, ever since the pandemic began, I have been following it very closely. Full disclosure, I'm not a public health person. I'm not a health person. I'm not a statistician. But just as a kind of economist and someone interested in data, the first thing that struck me, of course, following the pandemic was that if you looked at excess deaths around the world, it seemed that excess deaths per capita, which is probably the best way of comparing how different countries have performed. I mean, India was a complete outlier. First, of course, there were no excess death estimates in India, but if you look at the official death, India's official death per capita against excess deaths from the other countries was very, very low. And it somehow just didn't make sense because India's infection rates, which came out from the seroprevalence studies, were very, very high. The latest one showed India had about 70%. So how can you have 70 plus% infection rates and yet have such low deaths per capita? So that was the kind of motivation when we studied this. Just want to say that India, right, even today, India is not part of any global database on excess deaths because we still don't have reliable official methods of excess deaths. The Economist includes it based on their own model, but the Financial Times does not include India because there are no estimates. But then, a number of researchers, some of whom are on the panel, Murad, Prabhat, Brahma Mukherjee, started working on this early on. And then, of course, when the second wave hit, I think basically the intrepid work of journalists like Rukmini was then they started highlighting what was really going on in the pandemic. So just to say that this is not COVID mortality, but all-cause mortality. Also, want to point out that all the data sources and methodologies I'm going to show are highly problematic, each with their strengths and weaknesses. So the question was, should we wait or give up? And we decided to plunge into this to come up with estimates. Now, so in order to have some degree of kind of, I shouldn't say confidence, or some degree of reliability, we said we'd use three different sources and different methodologies to estimate these deaths. The first, of course, is the civil registration system, the CRS. And I'm going to defer to Rukmini because she knows much, much more than certainly I do on the CRS. That was the first data source we used. The second data source we used was Indian seroprevalence studies, which were actually very well done by the government, but then combining them with international estimates of infection fatality rates. And the third, a number of researchers, including Anup Malani and Sabarish, came across the CMIE database, the Consumer Pyramid Household Survey, and we thought we'd use all these. So let me quickly run through them. But essentially, the bottom line we came up with was we tried to estimate for each of these three, which are the three rows, and the two waves, to come up with an excess death number. And I guess what gave us a modicum of confidence is that all three estimates gave something in the range of 2.5 to 4.5 million for the combined deaths. This is until June. I want to specify we haven't updated this work beyond June. So this is as of June. It's something like between I would say between 3 and 4.5 million deaths, whereas the official number as of end June was 0.4 million. So somewhere between a factor of 7 to 10, the undercounting was happening. The CRS, as I said, I'm going to leave it to Rukmini. Essentially, what we did was to take the data that she had compiled for the states at that point in time. We had to make some assumptions about what happens, how much of an undercounting that those numbers represent based on historical data. And then we kind of basically extrapolated it for India as a whole to come up with the CRS number. But as I said, I think Rukmini will speak much more to that. The second was something that actually Murad first did early on, which is just to combine the seroprevalence with an estimate of the infection fatality rate. Now, the problem, of course, is that because deaths are not rightly counted in India, you can't really come up with an India-based infection fatality rate. So we had to use some measure of the international infection fatality rate, and we combined that and came up with a number. The problem, of course, is that you need to take account of India's age structure because age structure is quite crucial. So we take age-specific IFRs from, the CDC published its best estimates based on its own meta-analysis, and we came up with a number of about 4 million for the two waves, which revealed an infection fatality rate of about 0.54%. And Professor Brahma Mukherjee has just published a meta study of IFRs, and there I think the median estimate is close to kind of 0.5%. So this seems to be in the ballpark. See, the problem with this, I mean, as I said, this has problems too. We know that even the age-specific IFRs can vary in India relative to international estimates because, for one, there was a theory going around earlier that because of BCG, Indians were more immune to this. But then on the other hand, Indian health capacity is probably worse, which should increase age-specific IFRs. And also, we almost certainly know that in the second wave, age-specific IFRs must have gone up because I think of the shortages of hospitals, beds, oxygen, and so on. So really, this number is still not very firm, but we have to do the best we can. The final method was the CPHS. It's actually the only survey that actually in real time. It's not meant to record deaths, so it has a number of problems. It's come under criticism for not being representative, but it was the only data source that's in real time that we really have, and so we use that survey. The problem with that survey, there were two big problems with that. One is that you couldn't really replicate that for historical data, especially when you disaggregated it by age and so on. And also, this data showed a kind of inexplicable spike in mortality a year before COVID. So that's why this data source also has to be taken with a pinch of salt. But at least when you look at it visually, what the mortality is, there does seem to be something going on. So we made some very conservative assumptions about what the baseline should be, and we came up with this estimate of this. So let me conclude by saying that I think there are many ways of doing this. We try to do it in three different ways. Each of them have problems, which I just tried to spell out. But I think no matter what the way you do it, there's a certain kind of convergence in these estimates, which is what makes one feel that maybe these numbers are not implausible at all. And then if you apply these numbers back to the international excess data, then it seems like India goes from being a real outlier on the good side, i.e., very very low deaths, but becomes more like somewhere in the top quartile, which makes a lot more sense because India's infection rates are so much higher than around the world. So this puts India. So that's another way of kind of cross-checking whether these numbers make sense or not. This is my last slide. I just want to leave a couple of concluding thoughts with you. I think the title is Why Should We Do This? I think it's fair to say that India did pay a price for not having real good time data. And I think the way it manifested itself was complacency about the first wave. All of us took the first wave very lightly. And I think I don't want to blame anyone, all of us were culpable. We all thought that actually, India had escaped it. And there was a lot of complacency about the first wave, which I think led to our guards being dropped. And then the second wave suddenly hit. And then we know what happened. I think the second observation I would have is that there is really no substitute for reliable and timely official data. I mean, I think that is the best, that's the gold standard, and that's what we should aspire to. Having said that, we should also be honest and say, what if governments are not just economical with the truth, as we saw in this pandemic, but also there's kind of pressure on others not to be economical with the truth, not to shed light. And our approach and our spirit in this was therefore, as outsiders, there's only one option, that is to rely on science and the scientific method. use all sources of data available, national and international, be completely transparent on your assumptions and methodology, be aware of your biases and limitations, be careful about how you articulate these conclusions, and of course, let 1,000 flowers bloom, and it's really heartening, as you can see from the panel and others who are not, that there were so many, good faith estimates at this, and all these numbers converge. In that sense, it's a kind of tribute to the scientific method, and I think we should. My last thought here is that I think the real heroines and heroes of this story of India's counting is actually our journalists and civil society. I think I've named a few here. Rukmini, is kind of like almost like an icon on this now. The way they, fearlessly, tirelessly went after the data to give us the first kind of CRS numbers, and so many newspapers around the world. I think a number of academics like Gautam and Murad and others also did a great job. But the question I want to leave us with at the end is, I think the Indian scientific community needs to do a bit of self-reflection on this and ask itself, how did it contribute or not positively or not so positively to this? And that's why I think that in that spirit of self-reflection, I think this panel is a wonderful effort at that collective self-reflection, and I'm grateful that you allowed me to be a part of that collective self-reflection. Thank you very much.
Yeah, we move to Professor Prabhat Jha. So Professor Jha is the founding director of the Center for Global Health Research at St. Michael's Hospital. He's been a key figure in epidemiology and economics of global health for the past decade. He's been a lead investigator of the Million Death Study in India, which quantifies causes of premature mortality in over 1 million homes across the period of 1997 and 2014. His friends have described him as being professionally obsessed with death, and he's co-authored an extensive study recently which looks at COVID-19 mortality in India. I invite him to tell us about his conclusions. Go ahead, Prabhat.
Thanks to the organizers also for the invitation. What I'd like to do is very quickly run through my conclusions, which are that the first viral wave was very much characterized by widespread household transmission, but mostly low levels asymptomatic infection, and perhaps that explains the lower than expected death rates. The second viral wave saw only partial protection from the first viral wave, and the excess death proportions were much greater in the second than in the first. And in the second, unlike in the first, rural and urban areas were affected. And collectively, our estimates for both viral waves are in line with what Arvind presented, something between 2.7 to 3.4 million excess deaths, mostly in 2021, and substantially greater the official death rates. And we also conclude that with this correction, in fact, the Indian death rates are in line with the Western death rates. If we have time, I would like to talk about how we could move forward in the science about establishing a long-term adult vaccine program, but I'll defer that to the panel discussion. So let me quickly go through, a comparison of the 1918-19 global pandemic of flu, which might have killed perhaps 10 million people in India alone, 10 to 20 million, according to Kingsley Davis's research. And here you see the three peaks described in the UK. And this was very much occurring when soldiers from World War I returned. And there was the very large peak. But in fact, there was another peak after that. And flu didn't actually disappear for quite a few years and turned into the seasonal flu that we now very much have to battle every year. Now, the good news is even at the peak, the COVID death rates, let's say in the US, were only a fraction of those observed in the pandemic of 1918-19. The bad news is that we can certainly expect recurrent waves. So what do we know about the Indian patterns? Well, one study that we've done looking at self-referred populations, roughly 500,000 self-referred populations, which are clearly a biased population. shows the following. There's an M-shaped pattern of infection in India with reasonably high rates in children. It goes down in young adults and then rises again and to older ages and decreases. This is very consistent with household-based transmission. And if we look at these seroprevalence data in these 500,000 self-referred, the sharpest increases were in fact at the younger ages. So all of this is consistent with widespread household transmission occurring quite early. And different studies showed that most of the infections were asymptomatic. But despite all of this, there was very little protection against the 2021 viral wave. And that might well relate to the change in the particular variants that were occurred, or it might be some other factors that we don't understand. So what do we know about excess mortality? Well, this is the key lesson here is what is excess mortality during uncontrolled transmission? And this is the key message. And so using 3 different sources of data, let me conclude those. First, COVID was the main contributor to the excess of deaths in the pandemic months in both 2020 and 2021. The actual numbers are at least 3 million or about 3 million, substantially higher than the official reported. And with the adjustments, Indian COVID death rates are actually close to Latin America. Very similar conclusions to what Anup and Arvind have published. So the key starting point, of course, is to realize that most deaths in India remain without medical certification. So the UN says there's about 10 million deaths a year in India. 3 million or 30% are not registered. They're just not counted. But that's greater in women. It's closer to 60% in women are not counted. And of those that are registered, the 7 million, only 86%, or only about 13%, have medical certification. So the vast numbers of deaths in India do not have medical certification at the time of death. And you see this varies greatly across the states of India. So this slide puts our summary estimates from the 3 different data sources. And I'll defer the civil registration results mostly to Rukmini, who's following me. And I echo Arvind's congratulations to her and the journalists who have been really heroic in producing these data. But I'll focus on the national survey results and the facility-based data. So first, the national survey results rely on an ongoing political panel voting called C-Voter, which tracks since May 2020, it's been asking households if they have recorded a COVID death along with any COVID patients. And so what we did is simply track the rolling 7-day average of these, which is shown in the red, of how many households reported a COVID death. And we compared that to the dotted line, which is the percentage of households that would report any death. And that's based on the Million Death Study seasonal patterns over 14 years applied to 2020 to 2021. And then in the blue is the official daily counts of confirmed COVID deaths. And you see the blue and the red very much overlap. They're strongly correlated. But the key finding here is in the first viral wave, there was an increase, a modest increase, about 1% of households reported a death, but it abated. And then in the second, chiefly from April till June, there was a colossal increase, and up to 6% of houses reported a death. Overall, it was about, if you take the average of this area, it was around 4%. And that's just COVID deaths, and that's in excess of the expected all-cause deaths. Now, in a sub-survey within this panel, within this cohort, we've looked at 13,500 households and simply asked who was alive in January 2019 and who died. And here are the death rates. And in 2019, you see in this study, the death rate was very similar to what the United Nations or the sample registration estimates. By 2020, it had gone up to 10.5. And by 2021, it had more than doubled. And this shows the self-reported patterns of COVID deaths, which is shown in orange, and non-COVID deaths. And in the 2020 peak, you see, interestingly, an excess of the non-COVID deaths and a little peak in the COVID deaths. But by 2021, it had reversed. It was mostly a huge increase in COVID deaths, but also in non-COVID deaths. Now, what I conclude from that is actually both of these were COVID deaths. The understanding of what is a COVID death has changed over time, and it's now understood that it's not just respiratory infections, but can also be cardiac conditions that contribute. So overall, 4.5% of houses reported a COVID deaths, very consistent with the overall estimate. Let's turn to the second source of data, which is the Indian government's deaths in health facilities. So this is 2 lakh health facilities, mostly in rural areas. And what we've done is simply compare, in the gray dotted, the 2018-19 average, and then in the orange 2020, and in the blue 2021. And here you see in 2020 there is a modest excess, particularly in September, but a colossal increase in 2021. And when you look at that stratified by urban and rural, you see that the 2020 increase, shown in the gray here, was only in the urban areas, not in the rural, but the 2021, shown in the yellow, was in both urban and rural. So lastly, what we've got are two different sources of data with quite different methodologies, but remarkably similar conclusions. The excess deaths were about 30% on the national survey, 27% on the health facility, and then the civil registration data for 10 states where data were reasonably complete shows about 26%. So what are the conclusions? Well, despite the caveats for each of these data sources, it is clear that COVID was the main contributor to the excess. The actual cumulative mortality rate is substantially greater than the officially reported one and puts India into line with what is observed in Latin America. And this is the Latin American pattern in Peru, for example. You saw basically a doubling of death rates shown in the red versus the earlier time periods. And those were somewhat related to the reported cases, but not completely. So we can't rely just on case data, we need mortality data. So to share my conclusions again, the first viral wave was characterized by widespread transmission, but perhaps low levels of infection. Think of it as a very lousy vaccine that had very limited protection that managed to infect a lot of people. The second viral wave showed colossal increases, much bigger than the first one, and particularly affecting rural and urban areas. And cumulatively, this estimate is about 2.7 to 3.4. Going forward, the definitive proof of the quantification of the numbers of deaths in India would come from the sample registration system ongoing survey, which they survey about over 1.4 million areas all over the country, 1.4 million houses in about 9,000 randomly selected areas. That sample registration system data, if it were released, would provide the most definitive evidence of the excess mortality. And I certainly hope the Academy will encourage that to be released promptly and with a great amount of attention to ensure that the public and science is confident in its results. So let me stop my presentation, and I'm happy to take more questions during the panel.
Thank you, Prabhat. So now we move on to the third talk in the session. This is by S. Rukmini. Rukmini is an independent data journalist based in Chennai. She was formerly the Hindus and the Huffington Post India's data editor. Her work focuses on telling stories on socioeconomic issues using data. She lives in Chennai. I think of Rukmini as the data journalist who sees beyond the data to the people and the stories behind them. really practicing data journalism with a conscience. She's been at the forefront of calculating mortality based on civil registrations, as well as also helping in many ways to coordinate and support the work of a number of groups across India who study COVID-19 data. So, Rukmini, go ahead, 10 minutes.
Thanks very much. Thank you for having me. It's an honor to be among the leading minds of Indian science. Being a journalist without a background in science, I rely not only on the expertise but also the public spiritedness and even the friendship of experts. And I'm very thankful that many scientists, including many on the panel, including some as recently as today, have lent me a patient ear through my steep learning curve through the pandemic. This outreach by scientists is underpinned by a genuine public spiritedness and desire to do good. And for that, I and other journalists are deeply grateful. Professor Arvind Subramanian and Prabhaja have laid out what the CRS data and other sources were able to lead them to in terms of a national estimate of excess mortality. What I'd like to do is to talk a little bit about what went into getting these numbers in the first place and why we need not just good data science and statistics, but good data to count deaths during a pandemic, and what the role of the scientific and the journalistic community could be in achieving this. This will be the least scientific talk you're going to hear, but in a sense, I want to argue for the role of the semi-rigorous in paving the way for more rigor, for journalism to pave the way for more science. First, I want to talk about why it is that we needed to do this work around estimating the true toll from COVID, and to push back against the narrative that questioning official data automatically implies lack of trust or lack of support for the government. One might have a lack of trust or support in any government, but that is not the reason that all science minded people should have been taking a long, hard look at official death data from COVID. Some issues are institutional and predate the pandemic, as Professor Jha has laid out. India went into the pandemic with a death registration system that records only 92 of every 100 deaths. In Bihar, a state with 123 million people, just half of all deaths are registered, even in the most recent data. A third of all people who died received no medical attention. Apologies for the formatting here. And even in a state, 4 out of 5 deaths are not medically certified. And even in a state like Kerala, even pre-pandemic, the medical certification system was still far from strong. All of this meant that India would miss counting many COVID deaths, just as we know from other studies that India undercounts deaths from other diseases, including tuberculosis, malaria, dengue, and diarrhea. But some of the problems were new and exclusive to the pandemic. Again, I apologize for the formatting here. This shows, this is the official Indian guidance on recording COVID deaths. The Indian government's official guidance for recording COVID deaths says that if a person dies without being tested for COVID or had tested negative but displayed symptoms, the death should be classified as suspected or probable COVID-19 death. In practice, however, only people who tested positive and then died soon after with a clear progression of the disease are counted as COVID deaths. Reporting by me and others has shown that most states also had death audit committees which examined all death certificates and then that mentioned COVID and then applied filters and decided which of these were counted as COVID deaths. All of this further depressed the official COVID count. Despite this, the focus remained firmly on the case fatality rate, and this number was used to repeatedly claim that India was doing better than almost any other country, especially after the first wave, as Professor Subramanian has pointed out. As Murad Banerjee, who is on this panel, has said, instead of wondering what made India exceptional, the focus should have been on trying to understand what made Indian data exceptional. Early indications that there was something exceptional about India's mortality also came from sero-surveys, again, as Professor Subramanian has pointed out. So all of this cast doubts not just on the denominator, but also on the numerator, the official COVID death count. And then the second wave struck. The disconnect between what was going on in homes and in communities and the official numbers became just too stark to ignore any longer. Journalists who knew their cities well began to push back against official COVID death tolls that were clearly underestimating the devastation that they were seeing for themselves in their own cities. From crematoria and burial grounds, they reported how several times the official number of dead persons were being given funerals every day. Journalists also reported from rural India about a spate of mysterious fever deaths that were going untested, untreated, and ultimately uncounted. These were not scientific estimates, but they were big red flags. At the same time, we began to see the work that journalists and the scientific community were doing in the UK, in South Africa, and in Peru on excess mortality. In India, data for deaths from all causes comes from the civil registration system, as Professor Jha has spoken about. Now, we did try to access national civil registration system data, but it was not open, and we were told it would come with a delay of a couple of years, where it would probably be cleaned up with better perspective. But just as Professor Subramanian has referred to, the question was whether to wait or whether to plunge in now. And I think what many of us decided was to plunge in now. I had assumed that the CRS data was closed, but when I realized that it was possible to access state level portals that the government has created for the CRS, that's what I and other journalists began to do. The CRS is not a perfect source, but a lot can be said with it. And our reports, both mine and by others like in the Hindu, were clear about what the CRS could say, what it could not say, what possible sources of error were. And still triangulate with other data sources as well. Just to give you a quick overview of some of the things that we were able to do with the CRS and the different ways that that I did this. In Chennai, for example, I took the help of someone to scrape all death certificates which are uploaded on the municipal corporation's website and look at deaths in normal years and in 2020 and 2021. In Madhya Pradesh, I was able to look at CRS data specifically, which showed, as you can see by that light blue bar, a huge increase in May 2021 in deaths from all causes. And these increases were several times what the official COVID death toll at the time was. A similar sort of almost eerily similar pattern in Andhra Pradesh. The graph looks almost the same, just with the names and the colors interchanged. A similar huge spike in May 2021, again several times what the official toll for Andhra Pradesh was. The extent of this undercount factor varied substantially between states. The Hindu has been at the forefront of accessing CRS data from across the country, and the broad trend that it seems to show is that this undercount appears to be far more severe in less developed states, while states that reported high numbers of COVID deaths, including Maharashtra, Kerala, and Tamil Nadu, actually had a lower proportion of undercounting. That's the sort of broad national story emerging from state level data. I also try to triangulate by using other data sources like the National Health Mission's data that Professor Jha has referred to as well. My sort of broader takeaways from this is what the CRS specifically shows, but my broader takeaways from this. Throughout the pandemic, but for some notable exceptions, the media has been hamstrung in its reporting by the lack of open data. As you'll all know, even 22 months into the pandemic, we do not have an official website for district-wise and historical COVID data. We were all, until now, reliant on a volunteer-run effort, covid19india.org. And when the young volunteers who, for no money or recognition, who were running it, simply burnt out, the task has now fallen to other groups of public-spirited volunteers. The ICMR's data also remains opaque and is only presented at press conferences or in the form of research papers. Information on clinical trials for drugs and vaccines, approvals, and adverse event reporting has similarly been restricted information on all of this. This is how things were. Hopefully, things can change going forward. And part of the impetus for this will come if there is a consensus within the scientific community. From the scientific community, I now have three grand hopes. One, the work of pushing for better data and better data sharing has to happen now so that we go not just into the next pandemic, but the next state of even dengue or malaria epidemics with better data. Two, more of us should be pushing for open data and not be content with data being granted as preferential access, but to push for this public data to be public. And finally, the responsibility of speaking truth to power is all of ours. We should all have been pointing out the problems with relying on the official COVID death count, irrespective of other divisions, if not for any other reason than for this. It was just good science. Thank you.
Thank you, Rukmini. We'll now move on to the actual panel discussion. And before this, we'll add three more speakers who bring their own diverse perspectives to the discussion. We'll include the speakers you just heard into this panel, which will then take questions from the audience. So let's start this by hearing briefly from the new speakers. I will introduce them one by one and ask them one question each in the light of the three talks that you just heard. And I'll request them to curtail the responses to about 3 to 4 minutes, not more, so that there is time for more questions. So the first person in the session I'll call upon is Professor Manindra Agarwal. Professor Agarwal is a professor at the Department of Computer Science and Engineering and also the Deputy Director at the Indian Institute of Technology at Kanpur. He's received multiple awards. I just mentioned the Infosys Prize, the Shanti Swarupa Bhatnagar Award, and the Padma Shri. He's been involved in COVID-19 modeling, co-developing the Sutra model for COVID-19 spread in the country. But the question that I wanted to ask is something that relates very specifically to the topic of this panel, Manindra, which is mortality. You co-authored a report from IIT Kanpur that studies UP's pandemic response, suggesting that it provided a model for how to maintain economic activity while suffering a smaller impact on health and lives. But you've also said that in commenting about the mortality numbers, you sort of said there have been reports about more deaths in UP and elsewhere than recorded, but nearly all of them are either anecdotal or use partial data. But you've had access to state government data that might actually tell a different story from what we've been hearing. So I just wanted to ask if you would describe what your own estimates are for undercounting of mortality in the state of UP.
Yeah, thanks for the question. Let me answer it in the following way. The data for the deaths, as many of the other speakers have pointed out, really is very patchy and sketchy. Even the CRS data is not perfect, but that appears to be the best bet we have to get a sense of how many excess deaths have happened. But what is very important is, and I've seen many of the reports about our analysis of the deaths in various states, it's very important to use the right approach and right method to analyze those data. I'll just give a one simple example. If you count the deaths for during pandemic from July or August 2020 till now, you're bound to get an excess number than the estimate for the simple reason that during April, May and June last year, there was a very strict lockdown all over the country. Most of the offices were even shut down. So even natural deaths occurring in that 3-month period are more likely to get registered sometime in July, August and later. And that number is quite substantial. It's a 3-month period, so a quarter of the deaths in the year in the entire country. So one should, if you count things from July, August, you will be getting a wrong result. It's better, and that's what we did. We had access to the CRS data for UP for the entire year 2020. And when we looked at from January 2020 till December 2020, the number of deaths reported or recorded in the CRS for UP was about 3% more than the 2020 number. And we looked at the decadal growth, which is also around 3% every year. modulo the fact, see, the reason one has to take a long-term perspective is that year by year, as has been observed by many, there are unexplained peaks and troughs. I mean, that really reflects the, let's say, not so strong reporting methodology. So it's better to average out over an extended period. So at least for UP, and actually we did the same analysis for India overall as well, for the year 2020, there is about a 3% growth in the number of deaths over the previous years, again linking, and the decadal growth rate is also around 3%. So what this suggests or leads to the conclusion, at least to me, is that now second wave is something I'll come to later, but at least in the first wave, it appears that the excess mortality was not as high as some fear it to be, and certainly not as low as it is reported to be. That just goes without saying. But as we come to the second wave, I think we just have to wait out and see the CRS data for year 2021. Then we'll get a much better understanding of the number of excess deaths that have happened. So that's my view.
Thank you. So now we'll move on to Dr. Murad Banerjee. Murad is a senior lecturer in mathematics at Middlesex University in London. His main academic interests are in dynamical systems with applications in biology, chemistry, and medicine. But he's also tracked India's COVID-19 epidemic very closely using both modeling and data analysis. He's written extensively for the general public, as well as provided compact descriptions of his scientific work and thinking on social media. He's very well regarded as a source of independent thinking about the mortality impacts of COVID-19 in India. But let me just ask this specific question of Murad. You've been looking at different ways of assessing mortality at the level of, in rural India, at the level of individual villages, pulling in data from news reports, trying to get a bigger picture of what's happening and how to extrapolate it. In addition, of course, you're looking at Bombay, which you've done for the past several months. One point that you've noted is that the great majority of rural COVID-19 deaths in many parts of India have gone unrecorded. And you've said that the ratio of excess deaths to recorded deaths could be as high as 9 or 10, but with a lot of variation. In some states, Kerala, Maharashtra, etc., maybe between 3 and 5, undercounting. But Bihar, MP, AP to over 20. What I wanted to ask was, what's your sense of the different ways in which you can have undercounting? Is it, what sort of variations are there on this particular theme of where you can get it wrong?
Yeah. So first of all, I think Rukmini actually kind of laid out at least part of the answer to that question, which is that there are multiple filters which occur between when a death occurs and then when it becomes an official COVID-19 death. So I think that there are deaths which can occur untested in people who never had a COVID test because they never had access to testing. They might occur even after a positive test, but not occur in a hospital, in which case they're much less likely to be counted. They might occur after a positive test in a hospital and then get rejected by a death audit committee as not being a COVID-19 death. So that's another kind of filter which can cause a reduction in the numbers. So I think that there are multiple ways in which you can have undercounting. I think it's worth stressing that some of those are actually structural and long-term problems rather than very specific to the pandemic. And maybe those are things that learning that could be taken away from the pandemic would be how to address some of those longer-term questions about recording deaths. But certainly there are many different routes and many different reasons why you get this undercounting. And I do feel that quite early on in the pandemic, you started to get clues that this was going to be a problem. You started to see a mismatch between epidemiological data, what you were seeing in terms of serosurveys that several people have mentioned, and then what you were seeing in official death counts. And also another thing that was a kind of big flag was why you were seeing so much variation between states. So you would see different states with roughly similar levels of spread, according to serosurveys, sometimes roughly similar age structures, other demographic data, levels of development, various indicators of development being similar. And yet you would find that official COVID deaths were varying widely. And I think if we were to take away one important learning from this, it is that you need to take into account all of this contextual data and you need to treat it with respect. You need to say that hang on, there's something which doesn't add up here. It's worth investigating further. And then precisely how you do that might take time, and it might take intense journalistic effort, as we've seen. But eventually, I think you do come out with the true story, or at least something more approximating the true story, which is what we've heard from our speakers today.
Thank you, Murad. So let me now move to Professor Madhuchandra. She's Professor of Statistics with the School of Mathematics and Statistics at the University of Hyderabad. She's worked for nearly 2 decades in the application of statistical techniques to biological, medical, and engineering problems across multiple institutions, including Pune University, University of St. Andrews, and so on. She received the Jan Tinbergen Young Statistician Award from the ISI for her work in this area during the PhD thesis. So, Madhu, so the question that I had for you was that, as someone who I understand doesn't work directly on questions of the undercounting of deaths, but is otherwise expert in the uses of extracting information from big data, I was just wondering if you could shed some light for the audience on different ways in which statisticians might approach how to fill in the data gaps. What inferences can you make from limited or possibly corrupted data, such as the COVID-19 mortality data?
Thank you. One of my first observations is our involvement in getting or not getting data in time has sort of made us overlook some of the very critical things that in any death count should have been done. Even in a perfect scenario where you have data, see, death count is something that is right censored. In statistical terminology, we call it right censored because there is always a delay. So if you take a naive method of taking deaths by cases or deaths by even estimated infection, that is a naive and always underestimation. That's the statistician's point. Firstly, it should not be done. So you need to understand the behavior of this delay, which Murad also mentioned, that from the death occurring to it becoming a record. And I would say not even a death occurring, actually a case occurring, and that resulting in one of the outcomes, recovery or fatality. There is a delay, and that delay needs to be studied in a probabilistic or a mathematical framework to begin with, in a perfect scenario. And when we have imperfection, that becomes even more critical to actually not use ad hoc measures, ad hoc estimates, but study it systematically. And it is not just a theoretical talk that it can be done. There are delay adjusted CFRs already published and applied to global data and Indian data. So it exists. Whether I use a log normal or whether I use a Gompertz, it is possible theoretically to be done. The information gap that we have, it can be filled with a probability structure. We can go even further. We can even model it as a process so that we borrow information from neighboring or similar units, which right now we are actually doing. We're doing in an ad hoc manner. It can be done in a complete mathematically formulated structure. And another thing I feel is we are probably getting sidetracked. We're thinking COVID and it will probably end. Our study, so once again, probabilistic study is showing that the endemic component of COVID is quite strong. It is non-ignorable component. It's a probabilistic study because obviously it hasn't happened, right? It's a prediction, but it is non-ignorable, significant, and it has a temporal pattern. A temporal pattern meaning we are going to see spikes even in the endemic status. If that is the case, it becomes imperative to understand what will be the load, whether just on the medical facilities or in terms of interventions required, in terms of loss of productivity. In order to understand those, we need to be able to now project the amount of burden in terms of infection, fatality. It is going to we are going to see in future. So it is possible, and there are certain works that are already in place. Of course, some of those works have been applied to countries like Switzerland, where data quality is extremely good. But the way I see it, it is possible to extrapolate those work and apply it in our subcontinent as well.
Thank you, Dr. Bhattacharya. So let me start off the Q&A session with one question that I'm going to ask everyone to respond to in about a minute and a half or 2 minutes. And that's what I'd like to do, is to sort of ask what happens in the future. So to look prospectively rather than retrospectively. To ask what can we do to manage tracking mortality better? Is there any 1 or 2 points that you think should be at the top of the policy agenda in terms of change that you can suggest? I mean, all of us agree that the situation regarding mortality tracking in India is terrible, and we should change it. But what can we do in terms of policy? What are the 1 or 2? And I will start with Arvind, and we'll work our way in the same sequence that we did the talks.
So, a wonderful panel and very, very useful, perceptive remarks. So, firstly, I'm not a health person or a data person, etc. And so I shouldn't, and I don't want to comment on the details, but, having worked in government and being an economist or whatever, and knowing India in that sense, I have the following thought. Now, the following thought is, if the government is going to be less than forthcoming with data, it raises one set of issues. But on the other hand, if government says it kind of acknowledges what the problem is, the state of this, then I think there's another set of issues. So on the latter, I will leave it to the others to comment, because then it actually becomes a technical, scientific discussion. But the big question is, what if we have a situation like we've had in this, where it's really difficult, and Rukmini outlined that so eloquently. So the only thought I had, and I'd love to get especially people like Rukmini who worked on the ground reactions, is what we actually have in India is states collecting data via the CRS, and then and Prabhat knows this better. Then the center does this SRS, and then you kind of triangulated things. Now, given that we have such diversity, so many state governments in India, is there some way of incentivizing some states to do better, and then putting pressure on the states that are not doing such a good? I mean, is there some role for naming, shaming, competitive federalism, exploiting kind of the diversity of India itself, to put pressure on, endogenously put pressure on states to improve data collection? Because I think a point that Rukmini makes is very important, that finally it's good. It's GIGO, good stuff in, good stuff out, garbage in, garbage out. We are all at the stage of processing the sausage, but if the inputs that we get are weak and poor, the output by definition will suffer. So I'm just very intrigued and kind of exercised by can we put pressure on at least some states that may have better incentives and things? Is there some kind of process like that we can think of? That's my only
remark. Gautam, let me add to that in very specific ways. I've been thinking about how India could count the dead for much of my professional career, but I will make 3 points. First, what you do in a pandemic is very different than in the routine. In a pandemic, even crude counts will tell you a sense of what's happening with the week-to-week or month-to-month variation. And as you've seen across the different sets of estimates with lots of weaknesses of each, there's a very consistent picture because the signal was so large, the background noise was very much swamped. And I will make the point that in our review of the CRS, we did not see this bunching up and delay in reporting accounting for the excess. In Andhra Pradesh, for example, in 2021, 98% of the deaths registered took place within the previous 30 days, not earlier. And Rukmini has also published on this. So that's in the acute phase. Even crude systems in the acute phase can tell you what's going on. On the longer term, because we have to remember the routine killers are also going to be quite important to consider in monitoring of deaths. There's, I think, a two-part strategy. Improvements in the hospital-based reporting are needed. Now the Registrar General reports 50% of deaths are occurring in facilities. That's a substantial increase. So improving the medically certified causes of death and having that more timely reported is practicable. You're talking about 5,000 facilities across the countries that need a system in. That very should be possible. But for the vast majority, for the other part of deaths which still occur at home, there is just no incentive to register the death. And as you know, in a rural area, you can cremate the body very quickly without any government certification. So in that context, I think the ongoing sample registration system, which takes a random sample of deaths, needs to be strengthened. It needs a larger sample size to be able to provide district level rates. The last point I would make is a very simple one. The Census of India has always had this enormous praise for being independent. And in the same way, eminent economists like Arvind have argued for central bank independence on monetary policy. I would like to see statistical independence argued as a key for basically social policy. So I think thinking about structural ways that basically you protect the Registrar General, the NSSO, other statistical institutions to provide evidence unencumbered by the day-to-day political firefighting would be one of the things we should build out of this pandemic.
I have three very sort of nitty-gritty suggestions to make. One is that I agree with Professor Subramanian, and I think guarding against greater centralization of the CRS is important. This is particularly important because there are recent legal amendments, proposed legal amendments that move in the direction of greater centralization and taking some federal powers away. So that's of concern, and that is something I feel we should guard against. Secondly, I don't have an answer to the trade-off between privacy and the need for right. So one of the things that that will be interesting to track in Kerala, for example, is that since July, Kerala has begun to make even the names in its daily bulletin. It lists the age and sex of all deaths. They have added columns on district and name. This means that it provides an immediately verifiable tool to someone to check if their relative or friend is or is not on it. Of course, it raises privacy concerns, and I cannot say that I have a clear solution to how that should be structured. But we have experience from things like the NREGA's administrative system on how sunlight can simply improve reporting systems. And the last point I want to make about incentivizing the word Professor Subramanian used is what got me thinking about it. But my solutions are for the media, which is that systematically the media's way of reporting on numbers is to immediately describe a state with the high numbers as the one that's failing. So the state that if Kerala reports the largest numbers of crimes against women, that means Kerala is the most unsafe. If Maharashtra is reporting the most deaths, that means the pandemic is running amok in Maharashtra. We, by the media reporting this way, we do not create good incentives for state governments to accurately report data. And one of the things that I hope that the CRS, that our reporting around the CRS and the undercounting factor that we were able to show, I hope that this point can be made bigger, is that states that reported the largest number of deaths were probably just doing a better job of reporting rather than doing a poor job of controlling the pandemic. If these sort of incentive structures can be built in from the media and civil society, maybe that will go some way towards incentivizing states to do a better job, provided we don't centralize all of their powers.
Manindra, go ahead.
Yeah. So to me, the I think the most critical and important thing is, I think already has been mentioned, that the timely reporting of data. I think what is happening is that for reasons best known to the government, the data is not forthcoming that quickly. I mean, even CRS data, if you see, you have to wait for a year to get hold of it. I don't understand why not a like provisional data can be put out quickly, and then of course it can be over time improved and cleaned up. So if there is a timely reporting of data and government ensures that, then perhaps many of these issues will get, knowing that data will have errors. Even then, one has seen a trend of improved reporting of deaths in India. If you see for a 10-year timeline, the percentage of deaths being reported and recorded in CRS has gone up substantially. So one hopes that this will continue, and therefore, if only the government can report the data in a timely fashion.
Thank you. Murad?
Thank you. So first of all, I think that at the state level, at the level of different states, I think that there are some states which in some ways provide a model for how it could be improved. I'm talking about CRS data and timely reporting. And for example, Andhra Pradesh is very transparent about its data. In my experience of looking at their portal, you can get the data in real time, and it's quite complete. And in a sense, that's why we know Andhra Pradesh has been hit so badly in terms of mortality by this pandemic. I know that not every state can achieve the same levels of registration in the same kind of time frame, that there's a process and that there are kind of barriers to death registration, which are also there. So I do feel that what Professor Jha said about the importance of surveys, the SRS, the fact that sometimes these large government surveys take a lot of time to provide the data means that probably in the meantime, it's really important to fill the gaps with large-scale mortality surveys, specifically to try to assess the impact of COVID, of the pandemic, in states where the data is poor. And I'm thinking specifically of Bihar and of UP, two states where we have historically relatively low levels of death registration, where the integrity of the data which is coming out is very poor. Even of the CRS data which is available, it's very imperfect. And I think in those situations, we do need mortality surveying to fill the gaps. But obviously, in the long term, the hope would be that the twin processes of improving CRS data and routine mortality surveying would be able to give us a much more credible picture of what's happening if say, another pandemic struck in the future.
Thank you. Madhu?
I think most of the points I would have liked to say have been covered. I just have one observation as a statistician. I think there should be some kind of harmonization across the statistical or the authorities who are empowered to collect the data across the country. Because when we sit down and analyze, the discrepancy just across state border is so severe, then it cannot be just a cover-up. Sometimes it's the way a certain government agency in a certain state it is working compared to another, just the neighboring state. There is huge discrepancy. There should be some kind of benchmarking or standardization across these comparable government agencies within the country first. Otherwise, we are never going to get an aggregate figure of the country that will be reliable. That's all I can add as a statistician.
Thank you. So we have time, I think, for one other question. We're really running out of time here. So I'm just going to address this to Murad because it's a specific epidemiological plus data question. It says that IFR is based on data from unvaccinated people, and there appears to be a concordance of death estimates from IFR with those from other sources. Does this mean that vaccines reach too late to prevent substantial death, based on what we know?
I think that's a difficult question, and it's certainly a question which I've also kind of asked myself based on the data. I've seen projections and some work from Imperial College London which actually estimate how many deaths were saved by vaccines during India's second wave, and they estimate a very sizable number of deaths were saved. On the other hand, working against the vaccines, you had a possibly more deadly variant. The data that the Delta variant is more deadly is now quite considerable. you had a very rapid wave which rapidly overwhelmed health systems. There were probably lots of avoidable deaths. I mean, people who with proper medical attention, oxygen availability could have been saved. So I think you had these competing factors. So you had vaccination definitely very likely lowering the death toll, and at the same time you had factors pushing up the death toll in the second wave. But that, just a very small side point I want to kind of digress onto based on that, is that one of the things that we need to look at, and I have tried to look at, is how the timing of death, excess all-cause mortality, has coincided with what we understand of the pandemic. And the timing of the two has actually been very concordant. And that, I feel, is it's a kind of validation for why it's important, why these all-cause mortality estimates that are coming out from lots of different groups very likely do reflect pandemic deaths. They're not a reflection of underlying trends in registration. They're not a reflection of other unknown factors. They're a reflection of the severity of the pandemic, because the timing actually reflects very closely what we see in other epidemiological data coming out, for example, in case data and in official death data as well.
Gautam, may I add one comment to that?
Sure, go ahead.
Yes, so I think it's important to note in any of these estimations, infection fatality rates or estimations of R0, when you've got a pandemic, you also have a fair amount of heterogeneity of susceptibility. And often a lot of the models ignore the heterogeneity. So even the IFR estimates, early on, remember, the most susceptible population, and perhaps those with higher comorbidities, would die. So early measures of IFR tend to overestimate the IFR. But as you get the less susceptible population exposed, and perhaps because they have some background immunity, the IFR changes. So it's a very tricky thing to do. And similar biases occur, certainly in trying to estimate the reproductive number as variance changes. Now, I think one of the questions is, well, does that mean that India's got natural vaccination and therefore don't need the actual vaccines? Well, the evidence outside of India very much suggests that the natural vaccine is not, or the natural infection is certainly not as protective. And the same recurrence that we've seen in India occurred in Brazil, where they had high numbers of people infected. And they thought, well, we've reached herd immunity, which is a really silly concept, should be thrown out. And you saw a gigantic second wave of mortality. So this is the concern. Going forward, I think one of the science response ought to be to set up cohorts of Indians that, in fact, could have their serostatus monitored. There's large numbers that have been naturally infected and have had vaccines. So now having those followed over time, and there are ways actually that even the serologic assays, by testing for different antigens, can distinguish between natural and acquired or vaccination infection. So this is what you need going forward to be able to understand the patterns of this. So I think Arvind's point that we need an ongoing science response really is worth emphasizing.
Thank you. That's very useful. I'll now pass it over to Shashi to wind up the proceedings. We're well over time now. Shashi, go ahead.
Yeah, thanks. In the interest of time, sorry, we have to stop here because although we have several very good questions to all of you, the panelists and speakers here. First, I thought, I'll summarize, but again, in the interest of time, people have spoke so well. I don't think there is another translator required to what each one of you said. And just to summarize in 2 sentences, the need for this kind of a data to be collected during the pandemic itself is sort of, goes without saying. Not only, for example, if you are talking about public health, for any other kinds of diseases or another outbreak, whether it's epidemic or pandemic, is one thing. Second is, even now, the pandemic is not yet over. People are still talking about the possible third wave, irrespective of how many of us believe in this or not. But even for the as Prabhat also mentioned, even the ongoing vaccination program, we need to have some understanding of, the mortality, because the mortality not only in terms of number and mortality age-wise, both are equally important to strategize the vaccination program. Whether we need, what age group, how to sort of, speed up the vaccination program, and also how many number of, boosters we need to give. All of these things are equally important, and for this we need data. And given India's complexity, obviously, this is where the science and the scientists and mathematicians and the statistician and other data scientists have to come together to address this problem. I think that's what it's very clearly that has come out of this panel discussion from each one of you. Because there are multiple different methods. Each one different method also has its own, noisy sort of background, how the data is collected, whether it's through surveys or through some other proxy ways. So that's where I think data science and the statistics come into play to derive meaningful information, useful information, and which are useful for, for public health policy and for the future projects. It's irrespective of what the death number is. Sometimes it's maybe alarming, but I think what is more important for us is to use the data for future. Future means tomorrow itself. For public health strategies to deal with the current pandemic itself. So I think that's basically the highlight of today's discussions. And thanks to Indian Academy of Sciences for providing this platform for this discussion. And thanks to all the people who attended and asked some very nice questions. There are many more questions in the chat box and the Q&A. Perhaps, we'll collate all of them and send to all of you. And at some point, whenever you have some time, please do reply. We can collate and pass it on to Indian Academy of Sciences. Thank you very much, and good night to all of you.
Let me take this opportunity to thank all of you on behalf of the entire fellowship and associateship of the Indian Academy of Sciences for a wonderful panel discussion. Thank you, Shashi, and thank you, Jitu, for organizing this. And I thank all of the speakers and this panelists and Gautam, who actually conducted the entire program so well. Thank you very much. I think it was a very meaningful discussion. The one take-home message that I will take is what has been said by one of the vice presidents of the Academy, Manindra Agarwal, is that the government should release the data in quick time, irrespective of whether the data, there are flaws in the data, whether the data are not as clean as it should be. Many of us actually tried to get that kind of data in the beginning during the pandemic, and we completely failed. We did not understand what the hesitation was on the part of the government. We did not understand why this inhibition, even to pass on data or provide access to scientists. I think, I hope that that will erode, that kind of hesitation will erode, and we will be better prepared for future pandemics. Without data, preparation for future pandemics cannot happen, and the data needs to be released in real time. That's the kind of message that I take from this pandemic, but from this panel discussion. But also that in the face of lack of data, we underestimate big time, the various kinds of important demographic parameters, important health parameters. Also, like Madhuchanda said, that we believe that health is a state subject, and so the left hand doesn't talk to the right hand, and therefore there's this huge heterogeneity that many of the panelists have talked about, and I think some of those need to be weeded out. Otherwise, we won't be better prepared for the next outbreak of the next pandemic. Again, thank you very much, and greatly appreciate your participation in this important panel discussion. Thank you.